In all of our lives today, we are faced with problems so major and so massive in scale, individuals feel that they have no hope of ever fixing them. A worldwide pandemic killing thousands, rising global temperatures risking life for millions of humans and thousands of species, a plethora of incurable diseases that destroy or end the lives of millions of people every year, a poor understanding of the human brain that cripples research into cures for common neurological disorders, entire civilizations that starve every year due to lack of access of technology such as weather forecasting for agriculture. And the list goes on and on and on. So many individuals think that the only way to help solve these problems plaguing humans today is by spending large sums of money or going to school and learning advanced physics or medicine. But this simply isn't true. What if I told you that the device you are currently watching this video on right now has the potential to help scientists across the planet accomplish their goals to save humanity in advanced fields of science? Well, I'm here to tell you that it can. Scientists need the power of computers to conduct their research, be it simulation, the training of neural networks, or advanced mathematics. However, normal computers are far from capable of achieving this task alone. Usually, a scientific institution must make an investment to rent time at a supercomputing facility, or other institutions may try a different approach, such as using Amazon Web Services or even buying specialized computing hardware themselves. These solutions for achieving the computing power scientists need are held back by one thing: cost. Renting time at a supercomputer is a heavy investment and adds up over a long period. Purchasing dedicated computing hardware entails a massive upfront cost and implies the availability of IT staff capable of fixing and maintaining such a specialized system. So, how do we solve this problem? On May 17, 1999, the Berkeley Search for Extraterrestrial Intelligence Research Center created a software package called the Search for Extraterrestrial Intelligence at Home, or SETI at Home, that allowed users to run analysis on radio signals received by the SETI Research Center and look for transmissions from intelligent life on other planets. SETI at Home was the first ever software hosted by an official education institution that allowed users from across the world to run simulations on their computer and send the results directly back for use in scientific applications. 3 years later, on April 10, 2002, Berkeley expanded this software into the Berkeley Open Infrastructure for Network Computing, or BOINC, a middleware software package that allows a computer with the software installed to sign up for a computing project, automatically download work, complete the work, and send the work back to be used for science. It even has the capability to schedule times to run tasks, pause work when the computer is being used, and only use a certain percentage of the computer's resources, and host multiple computing projects at the same time. Today, this software, along with a few other software services, is the solution for giving scientists the computing power they need. Funded by the National Science Foundation and ran by the University of California, this software allows scientists to create their own projects and ask the users of BOINC to sign up and donate their computing power. The only expenses the scientists have to pay when doing this is buying a server to manage, send, and receive tasks to computers attached to their project. Currently, the official list of BOINC projects that you can sign up for is located within the software itself or at the website, boinc.berkeley.edu. Some worthwhile right now are the University of Washington's Rosetta at Home project and the IBM World Community Grid project, both of which are using volunteer computers to produce treatments for severe acute respiratory syndrome coronavirus 2, the cause of the COVID-19 pandemic we are currently facing today. These projects also aim to find cures for diseases affecting humans continually, including cancer and HIV. If you're not interested in medicine or biology at all, you can donate to projects like Einstein at Home, Asteroids at Home, Milky Way at Home, Universe at Home, and Cosmology at Home, all dedicated to learning, studying, and documenting outer space. If you enjoy mathematics, you can contribute to projects like Prime Grid, Yo-Yo at Home, Number Fields at Home, Machine Learning Comprehension at Home, and the Collatz Conjecture, or Amicable Numbers, to contribute to number theory. Or if you don't even like science, try Minecraft at Home, a new project dedicated to studying Minecraft and solving long-standing questions, such as finding the largest cactus in Minecraft, finding the seed and location of the mountain in the default server icon and texture pack icon, finding the seed of the panoramic title screen background, which has actually already been found already, and more. If you're not into BOINC at all, but still wish to contribute to science with your computer, try Folding at Home, a project currently home to the largest computational entity on the planet. They are currently battling the COVID-19 pandemic, HIV, cancer, Parkinson's disease, and other life-altering illnesses. At this time right now, we need distributed computing more than ever. The more processing power we can throw at this virus, the sooner we can have an effective treatment for it, the sooner we can stop losing lives to it, and the sooner our lives can get back to normal. Your individual computer may not seem like much, but in a collective effort of thousands or even millions of people across the planet, we can smash this thing. If you don't believe in a collective effort, take this for example. The Folding at Home Volunteer Computing Network, upon releasing their COVID-19 application in March, became the world's first computational entity to breach 1 exaflops of computational speed, which is 5 times as fast as the world's largest supercomputer, the IBM Summit. Today, it has breached well past 2 exaflops, meaning it would take over 10 of the largest supercomputers on the planet to match its speed. How is Folding at Home so fast when it's made of computers exactly like yours? Because it uses the collective power of hundreds of thousands of people crunching numbers for science and to help stop this thing. You may not think it, but anything helps, be it the slowest year 2000 computer or the fastest gaming computer money can buy today. It would truly mean the world to me if you considered helping science by installing BOINC or Folding at Home and help stop the crisis we are currently experiencing. This is a team effort. We're all in this together. Personally, I am using every single resource I have at my disposal to stop this thing, with an army of computers peaking at over 100 processing cores and an electric bill to support. But I'm just one person, and 5 months into this pandemic, we cannot afford to wait on other people to fix it for us anymore. Take matters into your own hands and help me stop this virus before it eventually kills everyone we love. Thank you, and goodbye.